And everyone should be in at this point.
Welcome to the Deal Center. While we're waiting for everyone to enter, please put your name in the chat, where you're from. We love to see who's here with us tonight.
Let's see who is joining us.
I see Jan Childs from RISA. Hey, Jan. I see Judy Ward.
Oh, wow.
We have some from Valdosta State University with us tonight.
Oh, welcome.
Piedmont Technical College, great. Thank you all for joining us.
I see some of our CSRA RISA friends. Lisa Reeder.
I see Juanetta from Mercer University. That's right down the road from me.
Yep, welcome, welcome.
We're going to get started.
We have some more folks joining. Please type in the chat box where you're coming to us from. We want to see where all you folks are coming in from. I see John
from Chicago,
from Georgia Gwinnett. Ooh, from Chicago, the Windy City. Welcome.
Hey, Dawn. Thank you for joining us tonight.
Oh, Dawn is on. Hi, Dawn.
All right, we're going to get started in just a minute. I still see people coming on.
Mm-hmm.
We've got some Georgia College friends with us. That's great. One more minute.
Please, as you come in, type in the chat box where you are coming to us from. We like to know where all of our guests and friends are visiting us from. Okay.
I like y'all's superimposed backgrounds. So cool.
Oh, thank you.
Thank you, Dawn. All right. Cheryl, I believe we're ready to get started.
Sounds good. And I'll just continue to admit folks.
All right, great. Good evening and welcome to the Deal Center's virtual learning series. I am Amy Reddick, the Birth to Pre-K Professional Development Specialist here at the Deal Center.
And I am Cheryl Cooper Smith, the Kindergarten through 3rd grade Professional Development Specialist here at the center.
This is the second session of our 10-part learning series on the science of reading. These learning opportunities are designed to take you on a science of reading journey with experts from around the country. Throughout this year, we will explore topics around oral language development, the phonological processing system,
whether it's,
Okay, little technical difficulty there. All right, let's get back to it. These learning opportunities are designed to take you on a science of reading journey with experts from around the country. Throughout this year, we will explore topics around oral language development, the phonological processing system, orthography, morphology, fluency, comprehension, and reading difficulties. Our goal is to share how science has proven the brain learns to read and provide you with practical application to enhance your knowledge and instruction with the ultimate goal of student achievement.
Thank you, Amy. Just a few housekeeping items before we get started. Our team will monitor the chat box. Please feel free to type any questions or comments in the chat. We will hold questions for the presenter until the end of the session for discussion during the Q&A. Any technical questions for the team will be responded to directly in the chat box. Also, this is a recorded session. Please be reminded that the Deal Center now offers continuing ed units for attending our professional learning events. All attendees are eligible for CEU credit. However, a few conditions must be met before you can receive these credits. To receive credit, a survey must be completed and submitted at the end of each event. More information will be provided at the end of the learning session, so stay tuned.
Thank you, Cheryl. I am so glad that all of you will have the opportunity to receive CEUs for tonight's event. This evening, we will learn how the advances in neuroscience have shaped our understanding of how brain development impacts language and literacy. I want to take a few minutes to gather your thoughts around this topic. We're going to do a quick polling activity to activate our prior knowledge. So there's going to be 3 questions, and I want everyone to participate. And remember, with Zoom polls, the answers will be anonymous. So I'm going to give you, let's see, yep, there it goes. And I'm going to give you about 2 minutes to read over the questions and answer them. So I'm going to stop talking, give y'all 2 minutes. Be back in a second. About 30 more seconds.
Looks like we have 37 out of our 55 participants who have responded.
Okay, let's give them just a few more seconds and then we'll share the results.
Okay,
thank you all for responding.
All right, here we go.
Wow, all right, let's look. Okay, let's look at number 1. Blank is a key predictive indicator of learning across all developmental domains. Let's see, for the first choice, visual spatial awareness, we had 18%, vocabulary development, 48%, executive functioning, 40%. Oh, wow, thank you all for responding. I can see why you would put visual and spatial awareness and vocabulary development, because both are important developmental skills in young children. However, tonight, Dr. Farran is going to take us inside the brain to learn more about how executive functioning is developed in young children and why this development is important for future success. So thank you for responding to number 1. Let's look at number 2. Number 2, true or false? There is a strong connection between home school literacy environment and children's language development. It is unanimous. True. Yes, that is true. We know that there is more to language development than genetics. Research has proven that the school and the home environment both play a vital role in language development. So thank you for responding. And let's look at the last one. Okay, number 3. Blank can weaken the architecture of the developing brain. And let's see, 3% put birth order. Thank you for responding. Nurturing home environment, we have 8%. And lastly, toxic stress, 98%. So toxic stress is the winner. Not only are we going to discuss building the brain tonight, Dr. Farran is going to show us how healthy brain development can be derailed by excessive or prolonged stress, and why this stress can have a damaging effect on early learning, behavior, and health throughout one's life. So thank you all for participating in this polling. You did a great job. As you can see, we have some very interesting topics to discuss tonight. Right, let's take this poll down. All right, thank you. Great job, really appreciate everybody's response. So, it is my privilege to introduce tonight's guest, Dr. Lama Farran. Dr. Lama Farran is an associate professor of communication sciences and disorders at West Georgia and a practicing speech language pathologist with many years of experience. With a background in early childhood education and neuroscience, Dr. Farran's teaching and research interests center on the early development of language as a basis for reading in typical developing monolingual and multilingual learners, as well as learners with developmental disorders such as autism and dyslexia. So without further delay, I would like to welcome Dr. Lama Farran.
Welcome, Dr. Farran.
Thank you, Amy. Thank you, Cheryl, for this nice introduction. Good evening, everyone. I'd like to thank you for introducing me, and I thank you for joining us this evening. It is my pleasure to be here. Thank you for sharing your evening with us. I'd like to start. Let me just share my screen. And here we go. And, all right. So I'd like to go over first is to really go over the outline for tonight's talk. And I will be starting by introducing very early structure of the brain, talk about the structure and function, and look at developmental differences together between young readers and older readers, and talk a little bit about the impact of reading experience, then present different views that have considered how reading develops, and discuss some risk and protective factors that we need to consider as we approach the reading brain and help children develop on the path for literacy success. Then I'll present some strategies for building brain architecture, and we'll end with implication for practice. So as a start, before we even start with the content, just let me share with you very briefly just a little bit about my background that Amy alluded to. But in addition to my interest in neuroscience and the brain and working, of course, on language and literacy, language as a basis for literacy, reading, I would like to share that my training and my current work has been really focusing on working across disciplines. And I believe that this topic is kind of, overdue. I know many others have approached this topic in terms of what neuroscience can teach us, especially working with educators. And I believe this is just perfect time for us to really work together and learn, not only learn from what neuroscience has to tell us, but also I would like to even look at it as far as taking the initiative and kind of ownership in contributing to that evidence. And we know many educators are doing just a great job in their classrooms, in their schools, in their early learning centers, in many respects. So when we're looking today at the content together, I'd like us to think individually and collectively how we can make a change in very young brains, and how we can really help caregivers to help these very young learners to build the brain architecture and put them on the path for literacy learning. So I would like to start by making sure we're all on the same page, and I know we all know what development is in general, but it is a term that has been really used very loosely. And I'd like to use the definition that Daniel Messinger uses, and according to which individual development is individual change that is normative, it is non-reversible, and it's relatively stable. It is sequential as well. And let me just move this. All right. So it is normative in the sense that everybody has it. Everybody goes through development. We all go through it. It is non-reversible in the sense that the brain is a system that reorganizes itself in response to experience. It is relatively stable, meaning there is no going back. So once it's set in motion, development unfolds and continues to happen. And then sequential in the sense that there are certain developmental milestones that must be in place before we consider later development. So for example, crawling happens before walking. And as we think about the content, I'd like us to all think in those terms that certain developmental milestones may be there at a certain developmental period, but in many cases, certain systems have not come online, and we need to take that into account as we consider what we do in our role in changing the brain architecture and helping caregivers in that process. So the question that I'd like to start with is why focus on early brain development? And I'll start by what Shankov uses. He says it is more efficient, both biologically and economically, to get things right the first time than to try to fix them later. Surely we could work on different things at different times, but the idea of working early and getting it right the first time minimizes cost, both in terms of developmental time and also in terms of resources, and making sure that that we cut costs at all levels. So by the time we start, when we start very early, there is increased differentiation of various areas of the brain. The learning. The learning that happens, from the very beginning, we know that infants is born with a height of brain development. And this is illustrated in when we look at the structure of the brain, how it changes in a very short period of time. Between 3 weeks and birth, we see massive change in the weight of the brain. So at 20-week gestation, for example, the brain weighs 100 grams, whereas at birth, it is 400. And by the time that the infant is only 3 years, the brain goes to 1,100 grams, which is very close to what it's going to be as an adult. So, so the adult brain is usually between 1,300 and 1,400. So that's not much difference. And that tells us there's a great deal of work to be done in the first 3 years. So what happens and how does the brain develop and what the ingredients are? And I'd like to start with that first slide that depicts the different components of a cell. And we start with the dendrites here. These are the branch-like structures that take information and pass it on to, to the cell body. So it takes information to the cell body, and then we have the axons. These are the long projections here that take information away from the cell body. Myelin is the sheath that surrounds the axons, and it does play a role in the health of the cell and also in the fast transmission of information. So how does communication happen between cells, between neurons? We have the synapse is, we see that the signal travels along the axon, and there's a release of neurotransmitter in the junction between the cells. So we have the transmitters are released here, and the dendrites are going to receive that and take it to the next cell, and that's how communication happens. So if we think about what happens at a brain level, at a behavioral level, so with an infant, for example, let's think of an example of a synapse or synapses happening at once. Here's an example of a child or a baby vocalizing, and mom walks in the room and provides responsive, just being responsive and showing positive affect, showing great facial expression. There's a great deal of oxytocin being released in the brain of the child and the mom, and then you have those connections happening. So synapses happen particularly when we have positive experiences such as the one I just described. Here's a figure that really depicts kind of the different developments that happen in a very short period of time. Of course, we know development happens prenatally, but I'd like us to focus on this area between birth and 3 years. And as you can tell, if you focus on that space between 2 and 3, and you just draw a vertical line, for example, right here, you see that this is where most of the action is happening in terms of synaptogenesis, which is, that formation of synapses that happens at a very fast rate. So between 3 months and up to 15 to 18 years, there's, of course, it's a big period of time where synaptogenesis happens, but most of the work, we can tell that it's, the peak of that work is going to be right here during this period. And that's another reminder that we need to be focusing on this developmental area as the area and the period of opportunity where we can provide quality input to infants and young children and work with what they have in place in terms of factors that may be risk factors and protective factors that we will allude to shortly in this talk. So just remember that the brain, even though we have all these connections, we have all these cells being in place by birth, and we do know that connections are ready to be made, and the brain is ready for making these connections. Here's a video that that's going to show us just how these experiences are important, and it's a short video, so bear with me. We're going to start.
A child's experiences during the earliest years of life have a lasting impact on the architecture of the developing brain. Genes provide the basic blueprint, but experiences shape the process that determines whether a child's brain will provide a strong or weak foundation for all future learning, behavior, and health. During this important period of brain development, billions of brain cells called neurons send electrical signals to communicate with each other. These connections form circuits that become the basic foundation of brain architecture. Circuits and connections proliferate at a rapid pace and are reinforced through repeated use. Our experiences and environment dictate which circuits and connections get more use. Connections that are used more grow stronger and more permanent. Meanwhile, connections that are used less fade away through a normal process called pruning. Well-used circuits create lightning-fast pathways for neural signals to travel across regions of the brain. Simple circuits form first, providing the foundation for more complex circuits to build on later. Through this process, neurons form strong circuits and connections for emotions, motor skills, behavioral control, logic, language, and memory during the early critical period of development. With repeated use, these circuits become more efficient and connect to other areas of the brain more rapidly. While they originate in specific areas of the brain, the circuits are interconnected. You can't have one type of skill without the others to support it. Like building a house, everything is connected, and what comes first forms a foundation for all that comes later.
All right, so as the video shows, we know that the general pattern of brain development is already in place. So it is genetically specified, but the brain is always ready to make these connections. And certain processes are going to be dependent on which period of development we're talking about. So by 20 weeks, we have most neurons are present. And at birth, approximately 100 billion neurons are going to be the majority of neurons that the brain will ever have. And by 3 years, the brain is 85% of adult size, and we see that 90% of a child's brain development happens before 5. What we see continues to need to be developed is that front area of the brain, that purple, the area in purple that is part of the prefrontal cortex that will be we will be talking about in the upcoming slides. So there's no question that brain development is activity dependent, and it's going to depend on what we do and the experiences that we provide. So every experience is going to excite some neural circuits and leave others alone. Those neural circuits that are used are going to be strengthened. The ones that are not used are going to be dropped through that process called pruning that you saw in the video, that is programmed death. So pruning is part of healthy development, and we know that lack of pruning has been associated with certain conditions such as autism spectrum disorders, for example. At the same time of synaptogenesis, we have myelinization that's happening, and even though it begins at birth, increases rapidly around age 2, it continues to develop. And that's very important for us to remember that children at first may not be as fast in terms of processing and in terms of acting, but gradually as this myelinization process unfolds and continues to develop, children become more efficient in, across several domains. This figure here shows us the difference in neuronal connections between a newborn and an adult, and we can see the stark differences, particularly when we're looking at the difference between a newborn and, for example, 9 months, and then we can see even more connections forming from 9 months to 2 years. The 2 years, we have the most number of connections, and it is at age 2 or 3. This is where the brain has up to twice as many synapses as it will have as an adult. But through the process of pruning, we get rid of these connections of these neurons that are not being utilized, and the brain will have the adult number of neurons that we'll be using for the rest of life. So here I'd like to start with the first question and making sure everyone is with me. So I'd like for all of us to really respond, and if possible, using your chat box. So on the count of 3, when I say 1, 2, 3, if we can just hit enter with our answer, either true or false. Okay. So you can, please enter your answer in the chat box, but don't don't hit enter until I counted 3, and it'll be just nice for all of us to respond. I believe it's just a demonstration of how we're going to have, just maybe more synapses here, more connections. So, so let's do this. So, on count of 1, 2, and when I say 3, we hit enter. 1, 2, 3, go. All right. And I see that, yes, so many. Thank you for your response. So by age 3, it is true that 85% of the brain has developed, and by age, if you recall, by 5 years of age, 90% of the brain has already is in place. Okay. So I would like to now just kind of focus on what we will be covering going forward. It is, as I just mentioned, that the focus is really on how neuroscience can improve or can really inform what we do to improve developmental outcomes for the whole child. And just listed here some of the key domains that we need to be focusing on as we embark on this. And just to consider a few, but these are really major areas or domains. These include language, social, emotional, cognition, and academics. And knowing that no one of these factors is going to be superior or more important. They're all important, but when we consider the whole child, particularly when we're talking about very young infants and children, we are really considering the first 3: linguistics, social, emotional, and cognitive. Academics will come later, and of course we work in that direction, but just know that we will be focusing on these a great deal. So next slide, this is where we start talking about brain structure. And it's going to be very basic, just basic overview of what the different parts of the brain look like. And just for orientation, this is the front of the brain here highlighted in blue. And this is the back of the brain. Similarly, we can look at the different lobes. So these are different lobes of the brain that are highlighted in blue, red, white, and green. And we start with the frontal lobe, which is responsible for self-regulation, social cognition, problem solving. The occipital lobe, which is responsible for vision and perception. Parietal lobe, where sensory motor perception and spatial abilities develop, and then the temporal lobe, which is responsible for hearing, language, memory, and social emotional development. And I'd like us to just think about all of these areas, all these kind of skills that we need to be developing. They all reside in different parts of the brain, but you're probably wondering what happened to reading. Where is reading? And reading doesn't have a specific place or a specific lobe. It's not housed in a specific lobe. And that's because reading is a new invention compared to language and cognition. What we know about reading is from models, neurological models of reading and other models. But this figure here shows the different components that are part of reading according to the old neurological model. And according to this, we see different centers, different parts of the brain being highlighted in blue. This is the visual center, or the occipital lobe that you saw in the previous slide. And so this is the back of the brain. Again, this is the front of the brain. So from the back of the brain, we see a word, for example, and we recognize, so this is visual images of letter. We recognize the letters. And this is the auditory images of the words. This is what they sound like. And this is the area that makes meaning, we connect meaning, and this is the area that's responsible for articulation in the front of the brain, the Broca's area and the motor center. Note that this top figure even though it shows important centers or important parts of the brain, it does depict the reading network as being unidirectional, where there's one direction of arrows going from one part of the brain to the other. The next figure here, at the bottom, is the modern vision of the cortical networks for reading. And in this, according to this model, we have multiple areas of the brain are involved. And what's interesting here, you see the stark difference between this and the old view, whereby the directionality, we can see bidirectional relationship between various parts of the brain. And we see so front, we have the various areas are communicating with each other, and I believe that's really important as we think about this model, because it does really speak to the advances of neuroscience, what we're learning from neuroscience, and this idea that has enabled us to look at the brain in infancy and even prenatally. So now we can see a whole lot more, and we can identify brain regions that are involved and associated functions, and make clear linkages between behavioral level and brain level. So when, for example, we look at a model like this, we can link the evidence in the brain to the behavior of infants and young children, which tells us what the needs are, so we can behave, or we can respond accordingly. So here's the second question that I'd like us to answer. Again, let's do the same thing. Enter your, please enter your answer in the chat box. Is it true or false that according to the modern vision of the brain networks for reading, the visual word form area resides in the frontal lobe of the brain? And we'll give it on count of 3. So 1, 2, 3, submit. Correct, that is false, and thank you for responding. It is not housed in the frontal area, it is in the back area. That's the occipital temporal area. Thank you so much. All right. Next, let me just, okay, the next slides, I'm going to just review some of the studies that have looked at the brain, and we're just looking at kind of the main finding, and this is the brain of young children starting with 4.7 years, and we have the next is 8.1, 11.4, and the adults are 19.1 years of age. And here we see the left on the top. This is the left side of the brain. This is the right. And as we can tell, there's minimal activation. With the youngest brain, we see more activation. We see right brain activation, not so much as the individuals get older. So when we're looking here, for example, look specifically at each age group, much more activation at the younger ages that decreases in a very systematic manner to a point where it's almost absent in adults. And this right activation initially when we're young, and this is coupled with absence of right activation as individuals get older, speaks to the lateralization of language. And of course, reading is a language-based or process or phenomenon. So the importance of really looking at lateralization as an important development that we need to consider as we look at early development versus later development of the brain. This figure here shows us different regions of interest. We have the inferior frontal cortex on the left side of the figure. Again, this tall bar is the youngest group, followed by the next youngest, and then the adult is the shortest bar. We see the gradual decline in the activation on the right, the right brain. So this consistent decrease as children get older is a sign or is an index of lettering of language and reading functions. So they move from the right to the left, and by the time they're adults, we see more letterization, meaning everything happening at, in the left side of the brain. So this is important because this story is also related to dyslexia and reading disorders. So what I'm showing here in this slide, we have, this is fMRI studies that looked at training of dyslexic children. So the dyslexic children, we see pre-intervention figure here is going to be on the right side of this slide. We see lack of activation, as we can see these, the black circle shows no activation whatsoever, which is typically marked by red. And then the purple, there's some activation there, but not much. So this is pre-intervention. And then post-intervention is going to be on the left side of your slide. We see clearly a different pattern where we see engagement, activation of the left side of both areas. So what we see in the there's no activation of the temporal parietal area or the frontal area, whereas in the left side figure, we see activation of both temporal parietal as well as frontal regions. What this means for us, though, is that reading we can train the reading brain to become better at reading. So children who have dyslexia, when they are provided with the right help, especially when the help is early, the earlier the better, but when help is early is going to result in positive outcomes. What's interesting is that, that engagement of the frontal area that we see more in dyslexic children before intervention resembles to what we see in very young children, where we see engagement of right hemisphere, but we also see engagement of the frontal lobe in the process of reading. And this is attributed to compensatory mechanism that both young children and dyslexic children use in the process of reading as, working on, compensating for their reading deficits. So next, I'm going to talk about the different components that are involved in language. Of course, social emotional well-being and cognition are really at the top. And I'd like to remind us that the brain areas, not all of them come online at the same time. So meaning when we're looking at the developing brain, we always need to keep in mind which areas, which capacities have been, or systems have come online, which ones haven't. And brain areas with the longest periods of organization are most important for developing self-regulation, problem solving, language communication, and social bonding. So some of the areas may not be really ready fully ready for developing children. And we're also reminded here that even though we have developments happening at different times, it is also important to remember that it is critical that we intervene, that we do what we can to improve reading outcomes very early. So the earliest possible would be better. As you saw with the previous slides, where we see explosion of brain development, brain growth, and development happening within the period of between birth and age 3 and up to age 5, but certainly the younger the better. As we look at reading and what constitutes reading, so of course we reviewed the reading structure and some of the function and how that differs developmentally and how that differs in the presence of dyslexia. We also need to consider how reading has been conceptualized and how it's been presented in research. And we have different views that I'd like to just highlight a couple that kind of like big, broad views. And the first is a cognitive view, according to which reading consists of components and consists of set of skills that we need to take into account in order to improve reading and get young children to be on the path of reading success. So Scarborough, for example, presents the rope model of reading that I'll go over in just a second. Bishop and Snelling talk about the extended triangle model of reading, according to which there's bidirectional relationship between phonology, semantics, and orthography, but also there's focus on the larger or the broader language context. Katz and Kemai focus on language as basis for reading, not only in typical development, but also as basis for understanding dyslexia and reading disabilities. And finally, Hart and Risley, even though this is not a reading per se model that pertains to reading specifically, but the focus on the word gap and the importance of language input in early development as a very important competency to improve or to to ensure reading or language development, which is a basis for reading. This is the model that I mentioned. This is Scarborough model, the rope model, that highlights the different kind of components. And according to this model, reading relies on different sources of information for it to develop. So skilled reading entails the combination of both language comprehension and word recognition, each of which consists of many subcomponents. And both of these are woven together to get the child to skilled reading, which is defined as the fluent execution and coordination of word recognition and text comprehension. This is an important model that has been basis for many, many research studies. It continues to be a powerful model. However, it does rely very little on the context in which reading occurs. So conversely, we have the social cultural view of reading development that focuses on literacy as a process that develops at birth. It is a process that's very much influenced by the child's home language, home culture, and it relies on the interactions that happen between significant others and the developing infant or child. According to this view, what's really important in understanding reading and its development is understanding the different ways in which people conceptualize learning, how they view, how they construct their knowledge, what are the the components, what are the different ingredients, and those, according to this view, are going to look very different based on the child's culture, based on the child's language or languages. So it is really important for us to consider that social cultural view in the development of reading. And lastly is the funds of knowledge that is very central to this view. And this is the idea that children come to the learning environment already equipped with vast knowledge. And that knowledge does not always look like what we teach in our schools, but it is still very important. And as educators and practitioners, we need to take those funds of knowledge very seriously and consider them as a foundation for our teaching. So build on the knowledge that children bring and consider children as very knowledgeable as opposed to blank slates. So both of these views have really informed our understanding of how reading develops. And even though many would consider them as polar opposites of each other, I would like to think that they are very complementary. Also, central to both of these views that I've reviewed very briefly is the importance of social emotional foundation as social emotional development as a foundation for language and reading. And this is the idea that infants are born with the capacity for social connection, for social emotional engagement. However, they are always needing that input of caregivers in order for that to be ascertained. So this brings us to question 3. So is it true or false the cognitive and social cultural views represent complementary views of reading development? Is that true or false? So please enter your answers in the chat box on a count of 3. Enter. 1, 2, 3. Enter. All right, and thank you all. Yes, it's true. That's kind of overwhelming majority. Thank you all. It is true. So we kind of think of these views as really complementing each other. Next, we are going to review some of the protective and risk factors that we think are important. And I just have this kind of view of a balance. We need to keep a balance between the two. Of course, ideally, you would like the protective factors to be really much higher in terms of their influence, or much more influential in the developing brain. But we need to consider risk factors and understand what they are, so we can really offset the negative effect. So these are some of the risk factors that we'll go over, and I'd like to start by going over some of those studies that are done, and they're neuroscience, neuroscientific studies. And we're going to focus on prematurity first. And in this study that looks at premature brain, so the study was conducted by Yale and researchers from NIH and Wayne State University. And it looked at fetal resting functional magnetic resonance imaging, or fMRI, to look at brain connectivity in utero in 32 human fetuses with normal brain anatomy, and 14 of which were subsequently preterm, born preterm between 24 and 35 weeks. The results show weaker brain neural connectivity in the left hemisphere prelanguage regions in fetuses that would subsequently be born premature. So this speaks to the importance of knowing when we know that we're going to have prematurity. We know prematurity has been associated with risk for certain disorders like autism spectrum disorders, like attention hyperactivity disorder, ADHD, attention deficit hyperactivity disorder, and also cerebral palsy. So knowing all of that, knowing the physical and the cognitive, language and reading deficits that could result from prematurity, we know that we need to equip that developing infant and the family with much more care, and provide all the stimulation that we can, provide what we know from neuroscience and best practices to improve outcomes. The other study that also looked at premature infants, this was by Fumagalli and colleagues, who looked at early stress related to NICU. And in this study, we have higher NICU-related stress. So this is neonatal intensive care unit related stress in 24 infants who were born very prematurely, was associated with reduced anterior temporal lobe, or ATL, volume at time of expected age, which in turn was significantly associated with low scores on the Griffith Mental Developmental Scale at 12 months chronological age. So here, what we're seeing here, the arrows pointing to the medial ATL, or the anterior temporal lobe, and we see that's underdeveloped. So we have decreased volume that's been associated with performance on standardized measures, but also related to stress in the NICU. This next study looks at deprivation, sensory deprivation. In this study, looked at 27 adults, 12 of whom were born with congenital deafness, meaning they had deafness at birth, and they used American Sign Language as their mode of communication. And of those 27, we have also 12 adults who were hearing, so developed hearing. They were hearing development as they grew older. So they were not signers, so they did not use American Sign Language the whole time, but they used ASL as a second language. So both of these groups, these two groups of 12 had good language input and good language communication in general. The remaining three cases where they had deprivation. These are individuals that did not have good language input when they were little, and the results show that there is aberration in the arcuate fasciculus, which is that structure in pink that you see on your left side of this slide. And it's important for us to know what this is involved, what this does. So the arcuate fasciculus is that bundle of fibers that connects the posterior region to the front region, and that's the results of the study demonstrate aberration in the development of the arcuate fasciculus. That's been linked to poor language input when they were little. So in addition to these kind of structural or functional abnormalities that we saw, we can look at other risk factors. We know that stress is one of the most important risk factors that we need to consider, particularly in the very young brain. But we need to kind of make the difference or understand the difference between the different types of stress. And here we see that stress can be positive. So an example of a positive stress is, for example, being late for an appointment and being stuck in traffic with, just nowhere to go, but you're late, especially for an interview. So you have increase in heart rate, and you may have intensified focus and mild elevation in the levels of the stress hormones. But this is positive because as soon as your car moves, you get to your appointment, everything's fine. The second example is tolerable stress, or the second type of stress. This is serious, but it's still temporary, with positive responses mitigating the negative effect of stress. So it doesn't stay for long, but you have buffering influence or relationships that kind of make things better in a short period of time. The third type of stress is toxic stress, and this is the one that has the most devastating consequences. So this is for the toxic stress. It entails intense and prolonged activation of the stress response system without positive caregiving, without buffering in those influences or positive relationships. So what this video is going to show us just what toxic stress is and just give us some examples. So we'll watch it together.
Learning to deal with stress is an important part of healthy development. When experiencing stress, the stress response system is activated. The body and brain go on alert. There's an adrenaline rush, increased heart rate, and an increase in stress hormone levels. When the stress is relieved after a short time, or a young child receives support from caring adults, the stress response winds down and the body quickly returns to normal. In severe situations, such as ongoing abuse and neglect, where there is no caring adult to act as a buffer against the stress response stays activated. Even when there is no apparent physical harm, the extended absence of response from adults can activate the stress response system. Constant activation of the stress response overloads developing systems, with serious lifelong consequences for the child. This is known as toxic stress. Over time, this results in a stress response system set permanently on high alert. In the areas of the brain dedicated to learning and reasoning, the neural connections that comprise brain architecture are weaker and fewer in number. Science shows that the prolonged activation of stress hormones in early childhood can actually reduce neural connections in these important areas of the brain at just the time when they should be growing new ones. Toxic stress can be avoided if we ensure that the environments in which children grow and develop are nurturing, stable, and engaging.
All right. So as we saw, stress can have devastating effects, and we can see that stress related to extreme neglect is shown here. So this slide depicts the brain of a normal 3-year-old on the left, and on the left side of the figure, and the brain of a 3-year-old child who has been subject of extreme neglect, and we can see the stark difference in brain size. We see how the one on the right is kind of shrinked. So the shrinkage is definitely a change in the structure of the brain that has associated functions that are going to be affected. The next slide shows, this is based on a study that was done by Langer and colleagues. In this study, it focused on looking at DTI, or diffuse tensor imaging, which looks at the water molecules along the brain fiber tracts in the left hemisphere. And it gives us an idea of how the information is flowing, also how the fibers are oriented in the brain. So it gives us an idea of flow. And as we see, the top part is, looking at panel A, we see it's depicting the fibers for the infants who have family history of dyslexia. And the part on the right-hand side, these are fibers for infants who do not have history of dyslexia. So those who have history of dyslexia, we can see changes in those fibers. So these are structural differences in the arcuate fasciculus. Again, just as a reminder, this is a bundle of fibers that connects posterior regions that are involved in comprehension, posterior region involved in mapping sounds and word recognition, with the frontal regions that are involved in comprehension of sounds and speech. And it is believed that these differences may have been present at birth. So clearly visible differences that we can, just by looking at both sides of the screen, we can tell the ones who have history of dyslexia versus those who do not. So what does all of this mean? It means that we really need to be thinking about what neuroscience findings tell us. They don't tell us the whole story for sure, but these are concrete changes at the brain level that always translate into behavior that is aberrant, that is less than optimal. But the good news is that there's a whole lot to be done. There's much to be done, especially when we find out early, especially when we know what the consequences can be, and also knowing how plastic and how responsive the young brain is going to be to experience, so we can shape that experience to improve outcomes. So now we're going to take a break. Let's take a 5-minute break, and it is 6:33. So let's say 6:38. We'll start again.
Okay, sounds good. Thank you, Dr. Farran. We'll be back at 6:38.
All right, so I think everybody should be back and we're gonna go ahead and start. Okay. So let's look at some of the protective factors. We did discuss the risk factors, and now we're going to discuss protective factors. And we start with self-regulation, executive function. We'll also touch on processing speed. And throughout, we'll be mentioning caregiver responsiveness as an important protective factor to stable caring relationships that children need. Also highlighting the importance of simple conversations, the back and forth exchanges that are important in important as a protective factor. And then also consider the environment, both in terms of language input and literacy input, and of course, early detection and intervention. We will not be able to discuss all of them in detail, but we'll touch on the majority of these. So we'll start with cognition as a key to language and literacy success. So intersubjectivity, self-regulation, and executive functions are key components. And here we're looking again at the prefrontal cortex. Again, this is the front of the brain. This is the back of the brain. The prefrontal cortex, if you recall, is the area of the brain that continues to develop after age 20. So it does go through protracted development, and we know that it is the area of the brain that is one of the newest parts of the brain, and it is by far the most vulnerable part of the brain that is most susceptible to stress. It is the one that suffers the most when we're exhausted, when we're tired, when we cannot think straight, when we feel lonely, and it's very important for us to consider that part. We know that intersubjectivity and self-regulation and executive function are really housed in the prefrontal cortex. This is where most of those developments happen. And intersubjectivity is or consists or entails shared emotion, shared attention, and shared intention. That shared emotion called attunement, it is a genuine, deep, and bidirectional connection that we form with a significant other, with an important human being in our life. That's typically the main caregiver, as the mother or the teacher, with whom we share attention. And through this shared emotion and attention, what develops is shared intention. The child initially, or the baby, shares emotion and attention, but maybe all the behaviors may not be very intentional at first, but they become intentional because of this deep relationship or connection that we form with a significant other. So the importance of social emotional climate, of building that climate and ensuring that climate is there, cannot be really more emphasized, and it is important for us to consider what that climate does to allow children to connect with to their world, and this is the case in typical development as well as atypical development. The executive functions are important, as you all noted initially in that question answer the beginning of this talk. We know cognitive executive functions are extremely important for every aspect of development from infancy through adulthood. It is one of the best predictors of academic achievement beyond over and above literacy, math, and IQ. This is a figure that I believe is helpful in reiterating this idea of protracted development for certain developmental, functions, and the development of the prefrontal dorsal prefrontal cortex. This is the area here highlighted in the square. We see it. We see that development between age 5 and 20. And I'd like to just highlight this stark difference in color, where we see red and yellow means underdeveloped area, where blue and purple means mature area. So we see that only when children reach 20 and beyond, this is only when we really see kind of the purplish area that we're looking for. So this speaks to the importance of looking at what systems, what has developed and what's being, which systems have come online and which systems are fully developed. When we interpret behavior, when we work with caregivers and young children. Give, for example, when we look at behavior of a child in the classroom, even in the preschool, we can look at their behavior. Perhaps we look at their behavior differently if we knew that maybe they don't know better. Their brain hasn't really fully developed, so they're not able to make the right judgment, and perhaps their behavior should be interpreted in, just knowing what we know about neuroscience and what it tells us about those functions and how they develop. Maybe we can interpret the behavior as not necessarily being defiant. The child is not just being a bad child. This is really related, could be strictly a function of an underdeveloped cortex, or area of the brain, namely here, the dorsal prefrontal cortex. So just kind of a reminder how neuroscience can really inform what we do. And if anything, it kind of helps us see things from a different lens, so we can adjust our practices and have this kind of bigger understanding of what development means. So there's no question that executive functions have been extremely important, and the good news is that they can be changed, they can be improved, and recent studies have indicated that certain programs that focus on the development of executive function in preschoolers and early school year using randomized controlled trials have indicated that these functions can really be improved, and they have a cascading effect on the development of reading and language in the early years. So some of the predictors of reading, we need to be thinking about those also in terms of protective factors, right? So when we think about what else we need to consider, what else can we improve, what's within our power, because not everything is, as we know. Some of those risk factors we have no control over. But there's a lot that we have control, over which we have control. And these are areas that we can certainly improve, and we can instill in our children, that, the children we work with. We can start some of those, we can start really with infants. In the infancy period, we can work on speed of processing by making sure that we present stimuli, we present information at a faster pace. We can ask the baby, we can sing and maybe increase our, our pitch, our engagement, our facial affect, and present information, just much faster. We can ask or elicit response, and while initially we may be slow in eliciting those responses, but once we have established this connection with the infant, we can really work on eliciting those responses at a much faster pace, and that's very important. Another way to improve speed of processing has been linked to just conversational turns and talking to babies, just infusing, providing that language, and that's really important. Just talking to children really matters, and the work of Farran and her colleagues speaks to that. Just great change, or noticeable change in the speed of processing when just children are provided with language, and talking to children really matters. Phonological processing is another area. We can focus on all components of phonological processing, namely phonological awareness in all its variations, and also working on phonological memory and rapid naming. We can focus on vocabulary, both receptive and expressive, as well as syntax. So initially we may not be able to really elicit words from a baby, but believe me, the babies are taking it all in. So focus on their understanding of syntax, on their comprehension, and expression will come later. Also focus on making sure we teach them letter names, make sure they know that very well, and work on their verbal short-term memory. So, making sure they can, for example, repeat after you. You can say a string of letters or string of sounds, or even start a rhyme and have them repeat once they start able to utter, able to vocalize in response to your elicitation. We can also work on object naming and also naming everything in sight. So we can be naming objects, naming actions, everything that we see in front of us. Give everything a name, and that's really important. And of course, the rapid naming that I mentioned earlier would be really important. We know that all these components that I mentioned as being important to target are going to really require the right context. And as much as it's important for us to work and make sure that children are very, very early on are having these great social skills and working in groups, before we really ask children or expect them to function fully in a group context, we need to ascertain that ability, the child is able, the infant is able to connect with a primary caregiver. And that primary caregiver can be you or me, or the main person in the infant's life. It could be the parent at home, but many of these children or infants spend majority of their time in centers and in daycares and in schools, and it's very important for us to consider what we can do. So making sure that this dyadic interaction is happening, that it is healthy and it's robust, is going to be our foundation for establishing what we call triadic interaction. That's when the infant not only interacts with the caregiver, but also with others, and eventually in a group setting. So how do we build brain architecture? There are several things that we can do. And I'd like to start by the most simple one. And this picture really depicts what we can do at a basic level. Make a facial grimace or any facial movement, moving the tongue, moving the lips, or even the eyes, of changing your facial expression, is going to elicit a response from the baby. And make sure you engage in that, what we call serve and return. So you provide, you initiate a communication bid, and that bid could be changing your facial expression, could be vocalization that you make, could be laughter, could be anything. And you wait for the child to respond. And you can do that by encouraging every communicative attempt, no matter how small, no matter how incomplete, and comment and label both actions and objects. Use multimodal cues, including, make sure you use words, gestures, as well as facial affect, and maintain that back and forth communication, what we call circles of communication. These are very tiny turn-taking skills that we can start with. And even if you can just do 5 circles initially and increase it to 10 and more as the child develops. So this video is going to tell us a little bit about serve and return interaction, how we can engage in that, and how it shapes brain circuitry. So we'll start with that.
The key to forming strong brain architecture is what's known as serve and return interaction with adults. In this developmental game, new neural connections form in the brain as young children instinctively serve through babbling, facial expressions, and gestures. And adults return the serve, responding in a very directed, meaningful way. It starts very early in life when a baby coos and the adult interacts and directs the baby's attention to a face or hand. This interaction forms the foundation of brain architecture upon which all future development will be built. It helps create neural connections between all the different areas of the brain, building the emotional and cognitive skills children need in life. For example, here's how it works for literacy and language skills. When the baby sees an object, the adult says its name. This makes connections in the baby's brain between particular sounds and their corresponding objects. Later, adults show young children that those objects and sounds can also be represented by marks on a page. With continued support from adults, children then learn how to decipher writing and eventually to write themselves. Each stage builds on what came before. Ensuring that children have adult caregivers who consistently engage and serve in return interaction, beginning in infancy, builds a foundation in the brain for all the learning, behavior, and health that follow.
All right, so as the video shows that that serve and return or this turn taking is foundational for learning language and for reading, also for reading development. And there are several things that we can do to improve language. And you will see as I go through the following slides, you're going to see that you do all of these, everything you do and more that is not listed here. But what's different perhaps is that we're going to look at those from perhaps from brain at a brain level, kind of think about what that could be doing. So this engaging in particular activity, what it could be doing to the child's development and of course the developing brain, how that's going to manifest in the developing brain. So we start with improving language through narration. And narration is important because simply watching and describing what you see, narrating what the child's actions are is going to create more connections. That's because you're using the language that describes their action. So describing the actions of the babies. As babies get older, we can add questions, and those questions are going to again create neural connections, and they're going to help them really map those the words that they hear to their meaning and and their of course experiences with these words, having been through those in previous sessions with you. So narrating everything, anything and everything is going to be very important, and I believe it's important because it doesn't require much in terms of having specific skills or degrees or so people from all walks of life can narrate and should narrate, because it does reflect, narrating is usually reflective of cultural practices. It is an important skill that we engage in and we model, so the child becomes aware, and once the child is able to talk, is able to narrate himself or herself and kind of engage in that dialogue that becomes kind of two-way instead of just one way. Another skill that we can engage in or we can focus on is storytelling, and that's again has no language boundary, and has no socioeconomic boundary or educational boundary. Really, people, all people, every person should be able to tell stories, and stories can be actual stories that we learned from books, but the ones that I find very interesting and the ones that are really going to click, going to be interesting for the baby are the ones where you can make stories and make them a character and make you a character. And you can build on that and keep adding to it every day or every short period of time. You can add to it. And that's going to help in recalling. So it's going to help with their working memory, helps the children with their babies with their working memory. It's going to help them recall language and using language, and it's going to make them recall past events. So working on memory, long-term memory and short-term memory, but also certainly working memory is going to be mostly influenced here. Storytelling is also reflective of children's cultures, and we have many cultures that rely on storytelling actually as a main medium for exchanging of knowledge, for intergenerational transmission of culture and knowledge. And by us really capitalizing on that, I think we can be more inclusive and make sure that everybody's involved in doing that. We can model that as practitioners and as teachers. We can model that to caregivers so they can do that and do more of that at home, because every parent is able to do that. The one that's highlighted next is vocabulary. In vocabulary, of course, we know a great deal about it, but I would like to add here is not to refrain from using big words and rich words. Rich vocabulary is very important. So the number of words that the children are exposed to is just as important as the depth of vocabulary. So we need that kind of breadth, but also the depth of vocabulary is important, has been associated with positive outcomes that are associated with future language and reading outcomes. So use familiar words. Always start with familiar words to kind of enable the child to really engage and connect with you, but add vocabulary terms and multiple meanings of words, and that's we call them polysemous words. So make sure you use that as you are talking to very young infants. And this idea that infants are they're very small, they cannot take they cannot take complex language. Also the idea that we can't talk to children or to babies with more than one language, that is not true. The research really indicates that the more languages we expose them to, and also the more expansive the vocabulary that we use, that's going to lead to much richer language and favorable reading outcomes. And the last one here on the list is decontextualized language. This is one of my favorites, and this is the idea that we could use language not only to describe the here and now, not to only describe what's in front of us in the immediate environment that the child is able to see, but also focus on on ideas and on things and events that have happened in the past that the child can really recall and connect to. And that's very important to talk about what's not available, and we can do that through very simple games like talking on the phone, pretending to talk on the phone, where you as a caregiver, you can go to the next room and call the baby and really have a long conversation. Talk about what you saw yesterday when you went on a stroller walk, and what you did and what food you ate and what you're going to do next, and all of that. So using language without necessarily looking at references that are in the immediate environment is going to be very helpful. And you can add to that complexity of language as children get older. This helps with recall. It helps with the ability to reflect on past events. So it helps the child to think about their own thinking and to take the perspective of you as you're speaking, and kind of think about what you mean without really being in the immediate view and pointing to what you're talking about. So you can discuss this, past and current events, but without really looking at what it is that you're looking at, without looking at specific object or event and describing it. You can just talk about that and use language in a more abstract way. That's very, very helpful. Decontextualized language has been associated with much more complex language outcomes, and has been very beneficial for the development of literacy skills. And self-regulation and executive function can also be used to build the brain architecture. And in the things that we do are so simple. We've been doing them for decades, and I'm highlighting really the obvious. You're going to think, what are we talking about? Peekaboo in a talk about neuroscience. Well, yes, it is very important, because with Peekaboo, games like this are going to really stimulate the child's brain in anticipation, where you have emotion. It's an emotion-laden kind of exchange where the baby is really looking expectantly, is expecting you and expecting you to uncover your eyes. And in that process, the child is really, working on controlling his or her impulses, right? So the first reaction of a baby is to really uncover it, and probably, the child's going to do that at first. But with training and patience and repeated exposures, you're going to find out that the baby will develop that sense of self-control, controlling the impulses, and kind of develop, and that's all part of what we work on in terms of executive function and self-regulation. That's going to be very important. You could improve or increase the complexity of games like peekaboo by having the child control his own timing, and also eventually work on dictating how much you wait or how long you wait, and providing important practice for the child to regulate his own emotions. So great way to work on self-regulation and executive function. The next one is dramatic play, and dramatic play is a powerful tool to to work with children on various aspects that are related to reading, cognition, and language. Of course, with dramatic play, you're going to have scripts. You need to know your role, and it allows the baby, very young infant, preschooler, to step out of himself or herself and take on the role of another person or another character. That means that the infant or the young child is going to learn about what that entails. Needs to remember what to say, and also needs to use language in a very different way to serve different purposes. During dramatic play, there's a great deal of perspective taking. So the young child is going to take the perspective of the character and kind of change and have that cognitive flexibility to learn about someone else other than the self, and that's going to afford another opportunity for furthering for the development of self-regulation and executive function. And the last one I have highlighted here is to incorporate movement and thinking. This is, again, engaging various parts of the brain. The developing brain is going to rely on that motor system. That's actually motor is also speech. Remember, speech is a motor activity, and thinking, cognition, where you engage various parts of the brain. Whenever we do that, we are really improving those connections between areas that are serving different purposes. And you can think of examples that are really great, is any activity that requires both speech and thinking. Think of, for example, Simon Says for children who are a little bit older. We can also think of how to making sure that children take turns in passing things. So they're saying and passing objects. We can work on also making sure to use things like musical statues, where they have to really refrain from moving. They have to also count and then stop, things like that. So these are going to be activities that are going to contribute to the development of self-regulation and executive function, because they're going to rely on connections across brain areas that are involved in the development. And they both, they all contribute to the development of the prefrontal cortex. And here we have some suggestions for building the architecture of the brain in terms of cognition. So processing speed is something I alluded to earlier, where we can really just talking to children and making sure they are engaged in that back and forth, and we can increase speed. We can do that either just having natural conversation, but also we can plan it that way so we are more systematic in our approach. So we could use, for example, a screen, a monitor where we can be showing them objects and asking them to name, but we can, naming would be something that they generate, but we can also think about how they can take it all in and maybe just, say it in their head, maybe showing them objects and asking them to name them. We can also flash cards in front of them and having them just, tell us or point to a particular animal when we flash maybe 10 cards, and they have to just point to one when they see it, and that helps in their processing speed. Another one is imitation of patterns. This is one of my favorites, and I believe it is a powerful one because we can take it from very simple patterns that we model in front of the infant and have the infant model what you do. It could be as simple as building blocks. Then you can make a train, and then you can add a driver. You can add things like that, just using blocks. But you could also look at patterns that are more intricate and more sophisticated. And by using those patterns, what we're doing here is we are enabling or basically inviting the child to think about different patterns, and when there's violation of a pattern that they build, they do the comparison with your pattern, and they also think about their own how to modify it, and with your help and scaffolding, they can really achieve the pattern that you have demonstrated. So that's one. And also it's important because not only it is, it is specific to cognition, patterns are really how we learn language. Patterns is how we learn different languages. We learn different languages because they have different patterns, how words are structured, the orthography is different in every language, and that's how we learn through patterns. Reading is the same, language is the same, cognition is no different. And I'd like to just, focus on those patterns. Could be with objects that they see, but you could use a screen, a monitor, or your iPad or anything like that to build those connections. So having those patterns in a different way, increasing that complexity, is going to really result in higher cognition. And then change routines and model smooth transitions. Children really very young children love routines, as we know. Some of them respond to changes in routines differently, but we can change routines after we have very well established ones. And we can change routines deliberately to ensure that the child has the flexibility and has the ability to really deal with that change. That adaptability is a big part of executive function. It is very important, and we know adults are better at it than young children. But we can do that with very, very basic change in routine, where, for example, taking turns, you may be expected to, rather than waiting to be the second in line, maybe now you need to be the fourth or the fifth in line, and change that routine where you, the child has to hold and has to basically wait and hold their impulses. So that's another way. And finally, repeated practice. It is all about practice. Reading, the more we read, the better we are at it. We become better readers. The more we use language, we become better language users. The more we drive, we become better drivers. If you all recall, everything that you learn at first is going to require you to recruit all your resources, and you're going to be dedicating all your attention to what you're doing. But with repeated practice, that becomes part of what you know, and you can build on it and increase in terms of complexity, so you become a fluent reader, and hopefully by third grade. So that's very important for us to keep in mind. And also, reading readiness is going to be needs to be targeted. We can change the brain architecture by focusing on reading specific precursors. And those include phonological awareness, that includes rhyming, manipulating sounds. This is, of course, very simple phonological awareness skills that we can increase them in terms of complexity and developmental appropriateness, where we change from rhyming and segmenting to perhaps deleting. We can work on elision, we can work on substituting sounds and or parts of words, and then work on shared book reading routines. This is, again, it's not new, you all engage in that, so it isn't new, but what shared book reading routines is going to do is going to give the child that sense of security, that social emotional bonding. Remember that oxytocin is going to be there when you sit and read and bond with a child, and you do that on a regular basis, that it becomes part of your context, the context that you create. So while initially the book is going to be what attracts the child to sit and read, eventually it's you as a caregiver. That relationship with a significant other is going to be the target of that shared book reading routine. So basically what we're looking here is not using the props, which are books, books being audiobooks or reading, actual hard books or hardcover books, or even ebooks. All of those are going to be important, but shared book reading routines are going to enable us, enable the child, the developing brain, to look at this context as a source of security, a source of bonding, and that social emotional bonding is going to be very important for the development of reading. And then you as an adult, you scaffold the reading itself, and you can infuse more complex words or more complex books themselves. You can do that as you interact with the child, and the child comes to expect that routine to be part of everyday life. And lastly, talk. I say talk. It is really all about language. It is oral language. We know it is super important. We know that all cultures, all people from various economic status are going to have language. And what's beautiful about language is that it doesn't need much tuition. So we know it is basis for reading, and we need to capitalize on that to ensure reading success in the future, and to prep the reading brain to be, to prep the reading brain for success. And lastly, I would say in terms of building the brain architecture, we need to focus on us as adults being healthy. As caregivers, we need our brain to be healthy, and therefore we need to make sure that whatever we covered throughout this talk, we talked a lot about stress, we talked a lot about these risk factors. We know that typically they affect not only children, but they affect their communities, their households. And as an adult, whether you are directly working with the infant or the young children, or you are working with the caregivers, I believe it's very important for us to seek support and to monitor our own health in order to give, and provide the responsiveness that we talked about, and the input that these children are going to use to improve outcomes. What implications this has for practice? We need to provide a safe and warm, supportive, stimulating environment for infants. We have a limited window. It isn't the only time where we can really provide input, but it is a window of opportunity that I believe we need to take advantage of, certainly before age 3. The younger, the better, the earlier, the better. It's never too late to improve developmental outcomes for an individual. The research, neuroscience tells us that even in the adult brain, the geriatric brain, there's still plasticity, and the brain is responsive to input. But we are, as Shankov said, and I said it at the beginning of my talk, that it is much better to get it right the first time, and to get it early, to get it right early. And what we mean by that is intervening early. So at any point, we need to remember that our current conditions of children in their in their living conditions are as important as past conditions. So we can do a whole lot about now about the present, because it's going to be the basis for future interactions and future development. And finally, this is the implications for practice. In order to impact the whole child, we need to address multiple factors that I have alluded to in my talk. We need to address them simultaneously, promote oral language in infancy to ensure reading by 3rd grade, and we need to engage in developmentally appropriate practice. This means that when we know some certain milestones have not been reached, either because the time hasn't come yet, or because of various factors that could be impeding that development, we need to make sure we take that into account and we work around it. And finally, we need to engage in our understanding and embracing of translational science, which is the idea that we learn from neuroscience a great deal, but we also have a lot to contribute. And as practitioners, no matter what your background is, no matter what my background is, we have a lot to say, we have a lot to provide. In working together, and I do not mean by this imparting knowledge on each other. It means that we really collaboratively work and think about our own individual contribution, but also as a collective in order to improve outcomes. And with that, this is the end of my talk, and I thank you for your attention. Any questions? Amy?
Dr. Farran, we did have one good question that came up around in the area where you were discussing the social cultural view.
Right.
And the question had to do with, are you aware of the significance of the critiques of the Hart and Risley's word gap as a social culturally bias?
Yes, and that is true, and that is an old. It is really considered a seminal work, but of course we're aware of the methodology that was used, and it's not necessarily, it is not socially culturally relevant or sensitive, but it is used just as an illustration of the importance of words, saying words or infusing vocabulary for the development of children across, socioeconomic status or backgrounds. But it's certainly not kind of the leading study. So I hear you, the person who made that comment, I commend you on that actually, because it is really not considered kind of the best study out there. It was though. And we all acknowledge, you probably agree with me, that it was central for starting, the dialogue and looking at what language is, and vocabulary in particular. It isn't vocabulary doesn't constitute all language or language components, but it is certainly an area of language where we see a big discrepancy across developmental groups and across cultural groups. That continues to be the case, even actually, when we talk about, individuals or children coming from different backgrounds, that's still the case even when we look at multilingualism. For example, vocabulary is always going to come, as one, is going to surface as one of the important skills that we need to focus on. So it was more of an illustration on my part included there. It is not kind of the answer to it all, but thank you for that comment. Yes, it is very aware of the critiques that surrounded that study. It continues to be used, and I use it just as an illustration.
Okay, we have one more good question that we're going to go to for the sake of time. Once neurons die off, can they reconnect later if stimulated?
Where if they die off, they're gone. So that's they're not there. But what the brain produces neurons, and it doesn't stop. So it does have the connections, I should say. It forms connections in response to to environmental stimulation, richness of language, and richness of reading, and all of those things that we talked about in during this talk is going to be instrumental in making those connections and making them strong. So it's not only about making connections, but remember making those pathways. So the reading pathway, for example, the reading network, if you will, as as we saw in that model, is going to be built. It's going to become robust the more we do of certain things, like like reading. The more we read, the stronger those connections are going to be, and that's what we need to focus on.
Well, it sounds like it's really important for you to be intentional from the start. So it's important for us to have this information so we can build that in.
Absolutely, and reading is unlike language, as we learned. Language develops naturally, but reading requires tuition. And knowing what we know, especially considering all the risk factors that we covered, we know that why not be intentional from the beginning? And
right.
and I mean real beginning, even before children are born. Starting prenatally. And there are a number of studies now that focus on that developmental period, and it's not too early to start there.
Okay, thank you, Dr. Farran, and thank you everyone who gave such positive responses. There's lots of thank yous and appreciation and value that was gathered from the discussion this evening. So thank you, Dr. Farran.
Thank you. Thank you all.
Yes, thank you, Dr. Farran, and thank you for joining the Dill Center tonight to share your knowledge on neuroscience and really how it's informed our understanding of language and literacy development. We at the Dill Center are thankful for your commitment to supporting our work and bridging the research to practice in our state. So thank you. And thank you to all of our participants for joining us tonight. It's been a great learning experience with Dr. Farran. Please join us in December for our next virtual learning event on supporting emergent readers' vocabulary development. I would like to introduce Garrett Cook, the Dill Center's research associate. Garrett's going to give us some details regarding the survey and the CEUs.
Thanks, Amy.
Sure.
Like Amy said, my name is Garrett Cook, and I am a research associate at the Dill Center. At the Dill Center, we operate through a model of continuous improvement, meaning that we're always striving to do better. A huge part of this process is gathering your feedback from today's event. To make things easier, we have decided to use QR code technology for today's survey. So, if you could please direct your attention to the slide that's about to appear on your screen, and pull out your smartphones, we could get the QR code technology up and running.
Okay. Can you see this, Garrett?
It's still loading.
Okay.
I will go ahead and say that in addition to the QR code, for anybody who has trouble with that, we will also be entering the link to the survey in the chat box. And I see a question, whether or not you need a QR reader downloaded on your phone. You actually do not. All you need is a smartphone with a camera.
Can you see it now? Is it viewing?
No, Cheryl, it's not viewing. We might need to just put it in the chat box and let them access it from there.
Okay.
Not sure what's going on with the screen. It says you're sharing your screen.
Okay. Let me try again. I see the link is in the chat. I don't know why it's not sharing. Try again.
There we go.
It's there.
It's there. Okay, I don't know what happened. Okay.
All right. Well, if everybody will look at their screens and follow the directions up at the top. So first, you're going to open the camera on your smartphone. Then you're going to aim the camera at the code to the far right that says Scan Me. Once you aimed at that code, a banner should appear on your phone, and you'll just simply click that banner, and that will take you to the survey. Now, the survey will remain open for exactly 1 week. So survey responses that are not completed by the evening of November 24th will not be captured. And I would like to also reiterate that CEU credit will not be granted without the completion of this survey. So please make sure you submit it as soon as you can. As part of the survey, you will also be asked to provide contact information that is required for CEU credit. If you would like to have confirmation of some kind that you completed the survey, please screenshot the closing page of the survey. The Deal Center also does not manage the CEU process, so if you need to get in contact with the Continuing Education Office, we have provided you with their contact information at the bottom of the slide. If any of you have any questions about the survey, please reach out to me via email, which is I'm about to send in the chat box, or feel free to call the Deal Center phone number, which will also be in the chat box. Thanks so much again to Dr. Farran for a great presentation, and thank you all for attending. Have a great evening.
I'm going to stay on for a few minutes for anybody that needs a little bit more time.
Yes. And we still have quite a few folks on.
Yes. If anyone's having trouble, would you please indicate in the chat box? Cheryl, you're muted.
If you're having any issues with the scan, feel free to use the link instead of the scan.
Okay, we're going to stay on for just 1 or 2 more minutes. And what, because, yeah.
Yeah, we'll give folks
Everybody.
2 more minutes and then.
If you're having any trouble with the survey, please indicate this in the chat box for us.
Okay, Amy, I think we're good.
Okay. Thank you, guys. See you next month.
Thank you. Have a good evening.
Thank you. Have a good
Bye-bye.
evening.
Thanks.
Bye-bye.
Bye-bye.